Okay, so today what I'd like to do is give you a little instruction on how to find planets during the daytime. I have found this to be a very interesting supplemental activity that you can do when you're solar observing, if you're having a public outreach event, or just if you're interested on your own to see planets that you might not otherwise see because it's daytime. I'd like to now show you a way that that can be done. And as you can see here today, we have a nice clear blue sky, and I know in advance that the planet Venus is going to be visible, and this is the best planet, I would say, for trying to view during the daytime. It's the brightest planet, and provided it's not too close to the sun, it's a good one to start with. Some of the other planets are also visible, but let's see if we can find Venus today. Now I know, looking at the planetarium programs that I have, Stellarium, Starry Night, Sky Portal, and some other programs like that that you can download or you can purchase for your computer or your iPhone. I know that Venus is going to be east of the sun right now, and I'm pretty sure that it's not going to be behind the tree that we have behind me here, but we'll see what happens. Okay, so what we have here, we have a tripod that I've kind of pre-set up in a location where I think it's going to be good to set the telescope. I have a telescope here. This happens to be a 10-inch LX200 telescope. It's a vintage telescope. It's an older scope. I think it's probably about 25, 30 years old, something like that. It is a GOTO telescope, which is the preferred instrument to use here, I think, for what we're going to try. It's all set here. I think that we can put it on here. I do have a finder scope here that we will use. It's good to use a finder scope once you're not pointed at the sun. I would not recommend pointing the unshielded finder scope at the sun. It will damage the optics if you're not careful. And so in this case, I'm going to say put the cover on it. Okay, so as I've said, we have a 10-inch LX200 vintage telescope, approximately 25 to 30 years old. We're going to use that here today on our observing session, and I'm going to put the telescope over here. It is a heavy telescope. If you have access to a telescope like this, be very careful. It is heavy. Weighs about 65 pounds. Ideally, if you have two people, it's a lot better, but with any luck I can do it here. I use this bungee cord to help relieve my shoulders, otherwise it's a lot of weight on my shoulders. And what we're going to do here, I'm going to orient the base of the telescope more or less in the proper direction, which is pointed towards the north. The control panel is pointed north. And let's see if we can get this to go in here. And I'm not going to tighten it up too much. I'm just going to put it on there loosely so that I can rotate the base a little bit. I'm going to take the telescope itself and rotate it to where I think it's horizontal. And the base unit here, I'm going to set the right ascension to 0. 0, 0, and then I'm going to rotate the fork assembly so that it matches the 0, 0 point. Ideally, we want this to be 0 also, but before we verify that, this particular scope has a bubble level actually in the control panel, which is really a nice option to have. Not all telescopes have that. This one does. That's a good thing. If you don't have a bubble level built in, you can get one like this, and you can put it right there. And I see the two bubbles are pretty close in agreement, but ideally what we want to do is have the telescope be as level as possible. That's number one. That's the number one thing we want to do. And so I can see here that this arm of the tripod here, this leg of the tripod is a little bit too high. So let's drop that down a bit. Okay, we're getting close. And I think this one might just need to come up a hair, just a hair. That's pretty close. Make sure all the knobs are tight. And I think this one might have to go up just slightly. That's about it right there. That is really, really close. Both bubbles agree. So we're good. It's very important for the telescope to be able to find objects for the base to be level. Now the other thing that we should do is check the calibration of the declination circle. I think ideally it should be at 0, and that would indicate that this is horizontal. And I think it's pretty close to being horizontal. I'm going to set my bubble here. It's not a real good indicator, but it looks like it's pretty close to level, so we're going to call that good. And the next thing that I'm going to do, I'm going to put the finder scope on. Now let me warn you about the finder scope. If you point the finder scope at the sun for very long, it will fry the interior of the finder scope. I have seen that done. You can do it for a few seconds, but if you do it very long, it'll melt this. This is all plastic. If it were metal, you could probably get away with it, but never point optics at the sun unshielded. So we're going to put this on here just momentarily. And I will uncover the main lens of the telescope. But we're not going to point that at the sun the way that is right now. What I'm going to do is I'm going to find something in the distance, and I'm going to point the telescope at that as best I can. I see a chimney on the house next door. I'm going to point to that. And then I'm going to check this and see if we're close. Looks like we are. Oh yeah. It's very, very important to have the optics of the finder scope and the optics of the main scope aligned. Okay, there is my chimney, and this might be just a little bit low, so we're gonna crank that up a little bit. We use these adjusting screws to do that. double check that again. Looks pretty good. I would say we're good. Make sure these are tight. And now I'm going to remember to do this. I'm going to put the cap on the finder scope, so when we point that at the sun there won't be any problem. And the other thing I'm going to do, I have a solar filter. This is the only way it's safe to point the telescope at the sun. These filters can be purchased. This is a Thousand Oaks optical. I'm sure there's others. You can make these. I've made them myself out of cardboard, and they're very good. These films are so dense you can look straight at the sun and not worry about damaging you, your optics, or anything. So we're going to put that on the front of the telescope. Like so. Make sure that it's tightly squeezed on. There might be a little bit too much felt there, but we're good. I'm going to put this back at 0 on the right ascension dial. And then I'm going to put this at 0 here. Like that. So we're good. We're level. And we're pointed north. Okay, now before we go any further, as I said before, we want the control panel pointed north. In other words, we want the telescope pointed south. Now these older LX200 Meade telescopes are set up in the home position like you've shown here with the telescope pointed south. The newer versions of these LX200s, the GPS style, for example, like the home position to be 180 degrees from this, in other words pointed north, but this particular version here wants to be pointed south, as you see here. And so what I have here is a compass in my cell phone, and I'm going to put that right here, and I'm going to try to get this as close to north as I possibly can. And it's a little bit hard to see here in the sun, but it looks to me like I need to rotate this just a little bit more this way. Right about there. Right about there is correct. Now I'm going to tighten this down so we aren't going to accidentally bump that and move it. That should be good right there. Now we're going to go ahead and complete the setup here. I have the power supply down here. This happens to be a homemade power supply from a repurposed laptop power supply. Put that in there. These telescopes require 18 volts. You can deviate a little bit from that, but you need 18 volts for them to work properly. Then we have the declination cable. Plug that in here like that, and the hand controller, put that in the keypad connector port. And once more we're going to verify we're at 0. We're at 0. We'll put our bubble level on here just to make sure we're level. Looks pretty good. So we're good. So now what I'm going to do, I'm going to turn this on. Sounds good. We heard a little beep. That's indicative of function. And it will take a few seconds for the system to boot up. This is an LX200. Okay, when it boots up, it'll come up and say telescope, and if you hit mode, the first set of numbers you get is the right ascension and declination, and at this moment it doesn't really mean anything because our scope's not oriented to anything. It's horizontal and pointed south. So we hit mode again. It's going to give us a local time. Now the time here says 2:26, and I think we're about maybe 2 minutes off. These internal clocks in these, since this doesn't have a GPS, there's no updating the clock automatically. It just has a crystal set inside of it that keeps track of the time, but it's not very precise. And over a few days it can easily lose a couple of minutes. So what we're going to do, I have a watch that's calibrated to the nearest second to the actual universal time. I'm going to use that to set the time here. Okay, so we got 1400, 25, 08, say. That's probably within a minute. And since we have daylight savings time, this is the central time zone, but we're on daylight savings time, so it's going to be +5. That's good. And I'm going to assume that I haven't checked that, but I assume the location's the same. We haven't moved it, but again, that's something you would have to program into this in order for it to work properly. So I think we're good. Now the thing that we need to do, we need to come back here and pick up the iPhone again, and I have a program here called Sky Portal, which is available, or Sky Safari. This is Sky Safari. That's a good program. I think Sky Portal is the same basic program, but we'll go with this. And let's see here, 2:26 is correct. And we need to find the sun. We need to find the coordinates of the sun right now. The coordinates of the sun. We need the right ascension and declination. If we hit mode a couple of times here. Okay, we get the screen that says RA equals and DEC equals, DEC equals. That's the screen we want, and I think if we hit GOTO, hit the GOTO, it takes you to the right ascension. And the right ascension of the sun right now is 13 hours. 36 minutes. 0.1 minutes would be 6 seconds, so we'll put that in. 06. Enter. And then it comes to the declination. And the declination of the sun is -10 degrees, 1 minute. And we have a plus degree here on the angle, so we need to change that to a minus. And you do that by hitting the west key. That moves the cursor to the left over the plus key. Then you hit the down arrow. That takes it to a minus. Then you hit the east, and that takes you back to the angle again. And then we type 10. That's 10 degrees, 01 minutes, and we don't worry about the seconds. Now, with any luck, the telescope will go to the sun. And as you can see, it's pretty close. It's pretty close. It may not be perfect. I wouldn't have expected it to be perfect, but it's pretty close. Now, as you can see here, as you can see from the shadow, you can see that our telescope may not be quite perfectly aligned with the sun. So what I'm going to do, I'm going to loosen this just a little bit, just enough so that we can rotate this. And I'm going to rotate that. And what we want to try and do is get the fork arms to be as skinny as possible. If these are as skinny as possible, that says we're pointed straight at the sun with fork. Now we can also see that the telescope is not quite aligned on the sun, and the reason you can see that is because we have a very elliptical shape here, and if we loosen the declination, we can rotate, and you can see what you want to do is get the shape of the telescope body to be as small as possible. And with any luck, and by gosh, we got it. We got the sun in here right now. If you do that, you don't even need a finder scope. But what I want to use the finder scope for is zeroing in on a planet. If we use the scope and we don't quite get to the planet we're seeking, we may use the finder scope. That's why I aligned the finder scope to the main scope before we set this up. But again, I've got this protected right here. I see the sun in here. It's way out of focus though, which is not surprising. Last time I used this was on the chimney across the street, which is way too close. So we don't have a good focus here for astronomy. So I'm going to try and focus it here. And it's always the wrong way. Whichever way I turn it, I got to go the other way. There we go, it's coming. Very close. Oh, we have some nice sunspots too. Now, the goal here, I want to get the sun as perfectly focused as possible. And then, I'm going to rotate this up. So I'm a little more comfortable. I can stand here like this, and then everything is kind of right side up. And there is the sun almost perfectly centered in the field of view. Now let me say something about field of view. What we have here is a 35 millimeter lens. It's a panoptic Teleview 35 millimeter. It's a wide angle lens. Whatever lens you have can probably work, but put the largest focal length lens in the telescope that you have. This is a 35, which actually for this telescope here is real good. This particular telescope is an f6.3 LX200, so the focal length of this telescope is only 1600 millimeters, which is pretty short for a 10-inch Schmidt-Cassegrain telescope. And when you put a 35 millimeter eyepiece on a 1600 millimeter, you can see your magnification level is probably in the 40 to 50 power range, which gives you a nice wide field of view. And you'll see why that's important when you try to find Venus, because you want to be able to see as wide a swath of the sky as you possibly can. Oh, we got some nice sunspots out there. Very nice. So we have the telescope aligned. It's pointed at the sun. It should follow the sun now for a while. So now what I'm going to do, let's see what happens here. And we're not going to uncover the finder scope until we point it away from the sun. So now what we're going to try and do here is we're going to see what happens. We're going to tell the telescope, it thinks it's looking at the sun. So now we're going to tell it to go find star number 902, which is the code, the Meade code for Venus. And sure enough, we have Venus. It's a magnitude -4, so it's very bright. And as you can see, the telescope moved just about where I predicted it should. It's a little bit to the right of the tree there, so we should be able to see it when it's if it's available. Now let's just take a look here, see what we see. Yeah, I think we got it here. I think my finder scope's a little bit out of focus. But I think it's on there. Now what we're going to do, we're going to take the main filter off. And what I'm going to do, once I've uncovered it, I'm going to put this dew shield on. And the reason I want to put the dew shield on is to protect the optics from sunlight coming in from the side. Oh yes, it's right there. It's almost perfectly centered. Not quite, but it's pretty doggone close. So I'm pretty happy with that. And I always want to slow the slew right down. I'm going to center that. Focus it. And right now we see Venus as kind of a gibbous phase. Very nice. Now once we've found Venus, we can actually synchronize on Venus by hitting and holding. You hear that little beep? If you hit the enter, hold on an object, it will lock onto that object in the computer memory. Now it knows that it's looking at Venus, and it'll follow Venus now probably for the rest of the afternoon. Now if we had other planets to look at, we could probably find them this way as well. Mercury is not very far from the sun. I don't think I'm going to try that here today, but I can tell you from experience it works. But it needs to be as far from the sun as possible because it's way too bright, and the contrast that you have against the white sky background is very difficult. But Venus is very easy to see, and it's a great object to take a look at during the daytime if it's far enough from the sun. In this case, it's probably about, I'm going to guess, 25 degrees, 30 degrees from the sun, something like that. It's far enough we can actually legitimately look at it in a safe manner. Now, this is a great way for you to look at things during the daytime that most people don't realize you can actually look at. Planets are things you can look at during the daytime. You can use this to enhance your solar observing activities that you might do individually or as a club for your public outreach or just for your own enthusiasm. You can take a look at planets during the daytime. I have looked at Mercury. I've looked at Venus, of course. Jupiter is relatively easy to look at as long as it's not too close. If Jupiter is on the other side of the sky, you can definitely find that in the daytime this way. Saturn might be tough. If you have a really clear blue sky or if the sun is just setting, sometimes you can find Saturn this way as well. Another method that you can use to find planets in the daytime when you otherwise might not be able to would be to lock onto the moon. You can tell the telescope to go to the moon. You can sync on the moon, and then you can go from there and find planets, especially if they're close by the moon. That makes it pretty easy and pretty effective. The further you go from the object that you've aligned on, the less easy it's going to be to center the object in your field of view. In this case, we were going from the Sun to Venus. Venus and Mercury are always close to the Sun, so using the Sun as your guide star is the way to go. So this was my presentation for today. I hope you enjoyed it.